Welcome you all in the course of Basic Electrical Engineering. In that, unit number 1 is DC circuits. These are the unit contents as discussed in the last lecture. And in our today's lecture, we are discussing about Kirchhoff's current law. In last lecture, we are already discussed Ohm's law, statement of Ohm's law, three forms of Ohm's law, what are the applications and limitations of Ohm's law. In this lecture, today we are going to discuss Kirchhoff's current law, and in next lecture we are going to discuss Kirchhoff voltage law. First, see, as the name indicates, Kirchhoff's laws. The German scientist Kirchhoff's, they are formulated two laws of electricity. That is two fundamental laws of electricity. In that, first one is the Kirchhoff's current law, that is KCL, and second one is the Kirchhoff's voltage law, that is KVL. These laws are very important for network simplification, or to solve any network we are going to use KVL or KCL. That is to find the value of voltage, current or resistance or voltage drop across a particular element. We are going to solve KVL or KCL. In this lecture, we will see first KCL, that is Kirchhoff's current law. We will see first statement of Kirchhoff's laws. The Kirchhoff's law states that the algebraic summation of all currents at a particular junction point in the circuit is always equals to 0. That means consider one point, that is point A. At that point, three currents are incoming, that is I1, I2 and I3, and two currents are outgoing, I4 and I5. Here the statement tells that all currents, addition of all currents or summation of all currents is always equals to 0. Means we can add I1, I2, I3, I4 and I5 is equal to 0. The mathematical equation of Kirchhoff's laws, that is summation I is equal to 0 at any junction point. We can write this statement in another way also. That is, the second way is given here. The algebraic summation of current flowing towards the junction point is equal to the algebraic summation of currents flowing away from the junction point. Means at a particular junction point there are two currents are current flowing through the away from the junction point and two currents are current towards the junction point. Means addition of currents away from the junction point is equal to addition of currents towards the junction point is nothing but our KCL. And last way, that is the algebraic summation of incoming currents towards a junction point is equal to the algebraic summation of outgoing currents away from the junction point. Means at a junction point there are 4 or 5 currents. Incoming current is 3 and outgoing current is 2. So we can add incoming current is equal to we can add outgoing current is nothing but our Kirchhoff's current law. Here are the some sign conventions where we can take positive and where we can take negative. Here currents flowing towards the junction are assumed to be positive, while currents flowing away from the junction points are assumed to be negative. Means those currents are flowing towards the junction point are considered as positive. That is plus I1, plus I2, plus I3. Okay. And second one is current flowing away from the junction point. That is considered as to be negative. Means minus I4, minus I5, minus I6. Likewise, consider a junction here, a network in that some currents are given. Here 5 currents are mentioned: I1, I2, I3, I4 and I5. In that the current direction of I1, I2 and I3 are towards the junction point, that is A is the junction point, and currents I4 and I5 are flowing away from the junction point. Means the sign of current I1, I2 and I3 are to be assumed as positive, and the sign of I4 and I5 are to be considered as negative. Here we can take the mathematical equation as the summation of all currents at a particular junction point is always equals to 0. That means summation of I is equal to 0. Next line we can apply KCL at point A. It gives the equation summation of I1, that is current flowing through the junction point. I1 is positive. I2 also current flowing through the junction point, that is we consider I2 is also positive, and current flowing through the junction point is I3, it is also positive. I4 and I5 are the current flowing away from the junction point, that is it will be considered as minus I4 and minus I5 is equals to 0. Just rearrange the equation, we will get the another equation, summation of I1 plus I2 plus I3 is equal to summation of I4 plus I5. That is the last statement as seen in earlier slide. The summation of all incoming current, that means I1 plus I2 plus I3 is equal to summation of all outgoing currents, means summation of I4 plus I5. Okay, this is the Kirchhoff's current law. All are getting this? Okay, take one circuit, one point. At that point, see what is the incoming current and what is the outgoing current. Take the incoming current sign as a positive and outgoing current sign as a negative and write the equation. Next one is the applications of Kirchhoff's current law. First application is circuit analysis. Means to analyze the circuit or solving complex circuits with multiple loops or junctions where Ohm's law isn't enough, finding currents in each branch. That is, if your circuit is only one loop, in that Ohm's law is applicable. But your circuit is complex network or complex circuit. In that circuit, there are two or more than two loops. In that case, we are finding the current through each branch. Then we can use Kirchhoff's current law at a particular junction point. Okay. Next one is electronic design. Ensure proper current distribution in PCBs, laptops, smartphones and ICs for reliable operation. Means we have to design a circuit in proper distribution of current. At that point you are using Kirchhoff's current law. That is incoming current is equal to outgoing current. We have to check all incoming currents. Addition of all incoming currents is equal to addition of all outgoing currents. Next one is electronic designs. Ensure proper current distribution. Means we have to design electronics as discussed in above. Next one is measurement systems. Design accurate voltmeter and ammeter. To design any voltmeter or ammeter or any measurement device, voltmeter, ammeter or multimeter, we can use Kirchhoff's current law. These are the applications of Kirchhoff's laws. Okay. In next lecture, we are going to discuss about Kirchhoff's voltage law. In that also, first one is we discuss statement, next one is the sign convention, and third one is the actual application of circuit analysis, and last one is the applications of Kirchhoff's laws. If you find this information is useful, please do share with your friends and stay connected with us. Thank you.